Mercury. Mercury is the closest planet to the Sun, but if you think that means constant heat, you're mistaken. During the night, temperatures plummet to a frigid minus 180 degrees Celsius. During the day, however, they can soar up to 430 degrees Celsius. This extreme imbalance happens because Mercury does not have a proper atmosphere to regulate temperature. Instead, there is only a very thin exosphere, incapable of retaining heat. Aside from temperature, there wouldn't be much reason to worry about weather on Mercury, but the real dangers come from the intense solar radiation and the complete lack of breathable air. In practice, Mercury receives almost 7 times more solar irradiance than Earth. Being the smallest planet in the solar system, it is covered in craters, cliffs, and rugged terrain, which would make any landing very difficult. The lack of atmospheric resistance doesn't help either. Slowing down a spacecraft would be complicated, increasing the chances of a high-speed crash. Landing during the day is out of the question due to the extreme heat, since even the most advanced spacesuits can only withstand up to 121 degrees Celsius, far from the 430 degrees Celsius on the surface. It's also worth remembering that a day on Mercury lasts almost half an Earth year because of its slow rotation. The night isn't much better. Minus 180 degrees Celsius exceeds the lower limit of spacesuits, minus 157 degrees Celsius, which would cause you to freeze. Your best option would be to attempt a landing in the so-called terminator zone, the region between day and night, where temperatures are more moderate. Even there, however, it would still be risky, since variations can occur relatively quickly. Pluto. After landing on Pluto and taking a look around, the first thing you would notice is the cold. In fact, if you looked carefully, you'd realize that all the liquid in your body would have completely frozen. There are 2 reasons Pluto is so incredibly cold. The first is simple: it's extremely far from the Sun, almost beyond imagination. The second, however, is that its atmosphere is made up of nitrogen, methane, and carbon monoxide. This mix manages to conduct the cold straight into your body. Think of it this way: if you're just standing around in freezing air, it's cold, but tolerable. Now, jump into an icy pool and suddenly your teeth start chattering, your bones are rattling, and your lips feel like they're about to fall off. That's because water conducts heat far better than air does. Now swap out the pool for thousands of tons of nitrogen, methane, and carbon dioxide, and you'll have a good idea of why taking even a single step on Pluto without a superheated spacesuit would be anything but a bright idea. Mars. Mars is the second closest planet to Earth, and among all 8, it is considered the most habitable. During the day, temperatures are far less extreme compared to Mercury and Venus, reaching up to 20 degrees Celsius in certain regions, which is relatively comfortable. The real challenge, however, appears at night or in specific parts of the planet where the temperatures plummet to minus 130 degrees Celsius. Another major problem similar to Mercury is the incredibly thin atmosphere. It is composed almost entirely of carbon dioxide with only traces of oxygen, which means there is not enough breathable air. This thin atmosphere also results in low pressure and high levels of radiation, both extremely dangerous for humans. On average, natural radiation exposure on Mars ranges between 24 and 30 rads, which is about 40 to 50 times higher than the average on Earth. In addition, the planet faces frequent and extremely violent dust storms, with winds that can reach up to 100 kilometers per hour. These storms can last for days or even weeks, sometimes engulfing the entire planet, and they would pose a significant risk to any mission. Therefore, any attempt at habitation would require sustainable, airtight, and highly insulated life support systems, capable of protecting not only against heat loss and dust infiltration, but also, and most importantly, against the dangerous levels of radiation. Jupiter. Now we arrive at Jupiter, the planet famous for being gigantic and for its somewhat brownish color. Although it is extremely deadly, Jupiter might be the least creative when it comes to ways of killing you. Why is that? Simply because of its massive size. What it really brings to the table is pressure, and a lot of it. The moment you appeared on the planet's upper layer, you would instantly be crushed by a force 1,000 times stronger than Earth's. But let's imagine you resisted that. Suppose your bones were strong enough to endure it, and that 1,000 times Earth's gravity wasn't enough to take you out. In that case, you would be dragged toward the center of the planet at the absurd speed of 49 kilometers per second. During this descent, the pressure would only grow more and more. The sensation would be like smashing through countless brick walls, being crushed over and over again. Every single meter downward would be a worsening torture. Eventually, you would reach the core of the planet, and at that point, survival would be absolutely impossible. There, the pressure reaches the equivalent of 3 million kilograms, forcing your body in every direction at once. No matter how strong you might be, at that point resistance would be completely futile. Uranus. From this point onward, the planets become truly distant from Earth, making the journey incredibly long. Uranus is one of the two ice giants, and the only planet in the solar system that rotates completely on its side. Its rotation is also faster than Earth's. A day there lasts only 17 Earth hours. Despite the name ice giant, this doesn't mean the planet is a solid ball of ice. In reality, its composition includes mainly elements heavier than hydrogen and helium. Just like with Saturn, it would be necessary to avoid its rings to prevent a fatal collision. Once you cross this barrier, you would find yourself surrounded by toxic gases, with temperatures quickly dropping to below -220 degrees Celsius, making Uranus the coldest planet in the solar system. If the extreme cold and poisonous atmosphere weren't enough, descending into the lower layers would bring even greater problems. The air would become increasingly dense, and you would be struck by constantly falling ice particles. Eventually, you would witness a truly spectacular phenomenon, a diamond rain, formed by the immense pressure that compresses methane into solid structures. But the wonder wouldn't last long. In this region, winds reach up to 900 kilometers per hour, and the pressure climbs to about 100 times that of Earth. In the end, these conditions would be more than enough to crush any suit or spacecraft attempting to withstand them. Neptune. Neptune is the second ice giant after Uranus and has a very similar composition. Being the farthest planet from the Sun, about 30 times farther than Earth, its surface is incredibly dark and cold. Just like Uranus, Neptune's outer layers are freezing, but as you descend deeper into the planet, both temperature and pressure increase dramatically. It is estimated that the core reaches around 7,000 degrees Celsius, even hotter than the surface of the Sun. The pressure is so immense that the methane in its atmosphere breaks down, forming solid diamond crystals that literally fall as rain. This spectacular phenomenon makes Neptune one of the most fascinating and hostile places in the solar system. Winds are another extreme danger. They reach supersonic speeds, among the strongest in the entire solar system, capable of surpassing the speed of sound. In many ways, Neptune can be seen as a twin of Uranus, extremely cold in its outer layers, toxic with crushing pressure and diamond rain, but intensely hot in its core. This makes it a planet as dangerous as it is mysterious. Despite its distant beauty, it is impossible to imagine life surviving in such a hostile environment. Venus. Venus is the closest planet to Earth, located only 40 million kilometers away. This means that the trip there would be relatively short, taking about 4 months. Its size and gravity wouldn't be major problems, since they are quite similar to Earth's. The first real obstacle, however, would be the beautiful yellow clouds visible as you approach the surface. Unfortunately, those clouds are composed of sulfuric acid, a highly corrosive substance that would destroy your lungs in seconds. But let's suppose you had an advanced enough suit to filter out this poison. As you descend toward the ground, visibility would drop drastically. The atmosphere of Venus is extremely dense and made almost entirely of carbon dioxide, which would severely limit what you could see. Then would come the unbearable heat, about 450 degrees Celsius. And if that weren't enough, only about 10% of sunlight reaches the ground, as the rest is blocked by the thick atmosphere. This would make the environment seem dark and gloomy. Moving your arms and legs would also be a challenge, not because of gravity, which is nearly the same as Earth's, but because the air is so dense that it would feel like moving through a heavy liquid. With a state-of-the-art pressurized suit, it might be possible to survive for a few seconds on the surface, but not much longer. The atmospheric pressure is crushing, about 92 times greater than Earth's at sea level. In a short time, the suit would be destroyed, and if the pressure didn't kill you, the sulfuric acid would enter your lungs once the seal broke. And that would definitely be fatal. And of course, we can't forget about Saturn. On this planet, the way you'd die would be almost identical to Jupiter. You'd be crushed by the absurd pressure the moment you tried to enter its atmosphere. And finally, we arrive at our home, Earth. It's about 150 million kilometers away from the Sun, and even though it's the only known habitable planet, it still carries a mortality rate of nearly 100%. Here, we all share the same destiny. Thank you for watching until the end. See you next time, take care, and don't forget to like the video and subscribe to the channel.